Ben?
I'm here.
Hello.
Okay. Okay. We will begin, Gabriela.
Okay. Thank you so much for doing this.
Don't worry, it's okay. Please.
Okay. I'll go ahead and start. And
Okay.
so question
All right.
3, in a pie chart, why are the slices or the sectors different sizes? Each slice represents a category, and the area of each slice represents the proportion of the total occupied by the category.
Okay. Let me see what was my answer.
Question 3.
Ben says each slide represents a category and the area of each slide represents the proportion of the total occupied by the category. Do you agree?
Yes. Yes, I agree.
I just want to check what was my answer. Just let me go there. Yes, I agree with you.
All right.
Okay.
Okay.
So then we're on question 4.
Okay.
You want me to take question 4?
Okay, Gabriela.
Okay. Chart and Pareto chart related. So my answer, I put the only difference between a bar chart and a Pareto chart is that the bars in the Pareto chart are order largest, smallest, going from left to right.
Okay, I agree with you. Ben, right.
I agree.
Okay. And the next one says, we conclude that P hat is normally distributed if, I don't know, N times P is greater than then, and N1 minus P is greater than then. Okay, question 5. Is P the true proportion or the sample proportion? I wrote true proportion.
Yes,
Correct.
I agree. Agree with you.
Okay.
And it says, what is N? And it's the sample size.
Yes.
Yes, I agree.
Question 7. If P equals 1/4, what is the smallest N that satisfies the requirement? And gotta put that formula. And parentheses 1 minus P equals greater than 10 is 40.
I agree.
Can you, we just need to follow that. Okay. Okay.
So really, to answer that question, you take 1/4 and you're going to take the inverse 4. Instead of 1/4, the inverse is 4, 4, 1 times it by 10.
Okay. Okay, thank you. It says, suppose N equals 24 and P equals 0.4. What is the mean of P hat? And I wrote it would be 0.4.
Yeah.
Yes, 0.4.
Okay.
So we're trying to find the standard deviation of P. So that would be, it'd be P 0.4 times 0.6 divided by what are we doing here? It's the square root, right? So divided by 4 point. So you got to take 0.4 times 0.6 divided by, it's actually not divided by the square root of it. It's just divided by 24, isn't it? Equals that, and then take that, the square root. So it's 0.1.
Oh, I lost Gabriela. Just let me maybe.
Oh, thank you for telling me. Yeah.
Okay, don't worry.
I lost the signal.
Okay,
Sorry.
okay. I don't. Can you please then explain me again question 9?
Sure.
The answer?
Yeah. So we're just trying to find the standard deviation of p hat, which is how you do that. You find the standard deviation by taking p times 1 minus p over n, and then take the square root. So if p hat is 0.4, times it by 1 minus p, which is 0.6. 1 minus 0.4 is 0.6. 0.24, divide that by n is the formula, 24, and then it's the square root, so it's 0.1.
Okay.
0.1, yes. Yes.
Okay, thank you. Gabriela, agree?
Yes.
Okay. Gabriela, number 10?
Okay. Use the following information to answer the next 4 questions. Which means that in average is 0.300. We want to determine the probability to get more than 35 hits in her next 100 at bat. N equals 100 and P equals 0.3. So, since we have P here, we need to, well, N is equal to 100. So, if we divide the 35 hits, which is X, with the N, will give us 0.35.
Okay, 0.30.
That will a P hat.
Okay, 0.35. Okay.
Yes.
Okay.
I agree.
Okay, Ben agreed. I agree too.
All right.
Okay. The next one, it says, what is the standard deviation of p hat? Here again, we need to use the formula, right? A square root of p, that it is 0.3,
Yes.
times 1 minus 0.3 again, divided by the 100. I'm not sure. I got 0.004, but I don't know if I am doing right in the calculator.
So it's not asking for the standard deviation. It's asking for the standard deviation of p hat. Right?
Okay.
So we wouldn't start with 0.3, we'd start with 0.35, right?
Oh,
Mm-hmm.
okay.
So if you do that formula, then you start with 0.35 and you times it by what?
Times it by 1.
right?
Now parentheses 1 minus 0.3.
Minus 0.35 if it's p hat.
Oh,
I might be wrong
oh,
here, but let me see. That would be 0.65,
No,
right?
right.
And then
0.5.
divide that by 100, right?
Right.
yeah.
And then
Yes, Gabriela says. Mhm.
equals and then square root. That's not right. Hold on. No, that actually that I think that was right. Let me do that again. 0.35 times 0.65 divided by 100 and then equals and then square root. It's 0.048. I am not sure that's right because if we do the other one, 0.3 times 0.7 divided by 100 and then do that square root, that's 0.46.
I got that.
Oh,
I
Yeah,
have that.
Gabriela got 0.46.
yeah, I think that's the
Yes.
right answer.
Oh, okay. Okay.
But what's confusing to me about that is I don't understand why the sample population is that when this is the true population that we did it off of. So I think it's the right answer, but I'm not sure exactly why. I'm gonna have to
Okay.
read.
Yeah. Well, I tried to do it a little too much.
Okay. What did you say, Gabriela?
I was thinking it a little too much, but the 0.046 is the right answer.
Okay. Okay, it's
Yeah,
okay.
I think it is too. But like I said, why would we do it off of this when this is P without the P hat? But I think it's the right answer too. I'm not disagreeing. Okay, next.
Okay.
Okay.
Oh,
Whose turn is it? I don't remember.
okay. I couldn't. 11 was my turn, but I got it wrong. Okay.
Well,
Okay.
we know what this score is, right? The standard deviation. So it's
Yes.
0.046. So you just have to follow the formula, right? Which is p hat 0.35 minus 0.3 minus p,
0.3.
and
Right.
then that's equals, divide that by 0.046. It's 1.087.
Yep. 1.037. Yep.
Does that make sense, Nydia?
Can you
Yep.
please repeat it, please?
Sure. The z-score formula that's in the manual is
Yes, yes,
p hat minus p over
yes.
the standard standard deviation of p.
Okay.
So we already knew what the standard deviation of p was, right? Because we got it right here. It's 0.046. So then all you have to do is
Yes.
take p hat minus p and divide it by 0.046. And so the p hat we knew was 0.35, which was this 35 divided by the 100. And then the p
Yes.
was 0.3. So it's 0.35 minus 0.3. Take that number, divide it by 0.046. Is the formula to get the z-score.
Okay. Thank you. It's better now. Thank you.
All right. What is the
Should I go?
sure?
Okay.
Okay. It says, what is the probability Brittany hits at least 35 hits in her next 100 at bat? So we put the t-score into the applet, which is that 1.087, and it's right skewed, so to 0.139.
Okay, you said, okay, 0.139.
Yes.
Okay.
The only thing I disagreed with what Gabriella said was I don't think it's right skewed. I think it's left skewed, but it's the same answer.
Okay.
Oh, okay.
I might be wrong, but that was my take. It was the left skewed.
All right.
Okay. Thank you.
All right. Is it my turn now?
Yes.
Okay. If the true proportion, excuse me. Okay, sorry. My child was doing something here. If the true proportion of people who support a political candidate is 52%, and in his 2,000 people are surveyed, we want to determine the probability that the results of the survey will suggest the candidate is losing the election, getting less than 50% of the vote. So the standard deviation candidate is probably so the survey is just candidates losing the election. So I think it's 0.5 minus 0.52, 0.02 divided by n, 2,000, and then square rooted. No, it's got to be wrong. So let's try that again. 52 minus 50. What's that? 2. No. I'm doing it wrong. That's the z-score. I want the standard deviation. So it's 0.52 times 1 minus p. So that's times 0.48 divided by 2,000, and then the square root. So it's 0.011.
Yes, 0.011.
Yes, Gabriel agreed. Okay. Okay. What z-score would you use? Can you please help me? I continue lost.
Sure. So it's that same formula from up above, just the z-score. So the z-score is going to be now, is the p hat, is it 49 or is it 50? Gabriella, what's your thoughts there?
I thought it was 0.5 in this one. Oh, no.
I think it is 0.5 too.
Okay. All right.
So that's the formula says p hat minus p over the standard deviation, and that's your z-score. So p P hat minus P, that's 50%, because what we're trying to figure out is if you only got 50% of the votes. Okay, so that's the P hat. And then the P is 52, so that's minus 2 divided by 0.011
Oh.
equals. So I don't think that's right. Hold on just a second. What if we went 49 minus 52? What if it's 3 divided by 0.011? 3 divided by 0.011. 49 minus 52. Oh, that's what I'm doing wrong. Okay, so that's 0.45 minus 0.02. See, no wonder if we go. Sorry, I'm rambling, but I want to look at this, right? 49.9 minus 2. I'm getting 1.82, but that's not what I got earlier. This is one of the few I actually did.
Okay.
Gabriella, what did you get?
Well, I got minus 1.79.
So how'd you get it?
Formula to see for let me see what I put here. 0.5. Not sure.
I'm not sure what I'm doing wrong because minus 52 divided by 0.011. That wrong. I did 1.82, but I got 1.79 earlier too.
Mhm.
I'm not sure.
Sorry.
Let me look at the Z, P hat minus P over standard deviation.
Okay.
So the number must be, let's say it's maybe it's 0.49 as 0.52. That would be 0.03 divided 0.011. I bet you that's what it is. Let me try that.
Okay.
0.49 minus 0.52 equals divided by 0.011. That's more. What is wrong? It would have to be bigger than that. So if the true population of people who support a political candidate is 0.52 and N is 2,000 people are surveyed, we want to determine the probability that the results of the survey will suggest the candidate is losing the election, getting less than 50% of the votes. Less than 50%. That's got to either be 49 or 49.99, right? Am I missing something?
No, you're right.
I don't think so. I think you're right.
I'm banging my head against the wall because if we use 0.4999 minus 50.52 and then divide that by 0.011, it's 1.83 actually. 1.83. If it was 50 minus 0.5 or 50.5 minus 0.52, 0.02 divided by 0.011. That's 1.18. So it would have to, the probability of losing the election. In order to get the 1.79, I think you'd have to almost go 51 minus 52 minus 1 or 0.2 divided by, that's 0.9. I'm thoroughly confused. Did you
What do
actually
you think, Gabriela? Oh, sorry.
Did she actually try that answer in the system and it said it was right?
Gabriela,
Yeah.
did you try the answer before?
Yeah.
Not
And
yet? Gabriela?
Well,
Hey, Gabriela, did you try that answer before?
yes, the one minus 1.79. Yes,
And it was right?
it was correct.
Oh, Gabriela says
I
it
heard.
was correct.
Well, let's go with 1.79. I don't know how we got it though, so we'll have to do some research there, or I will at least to figure, because I don't understand it. But okay, let's move on.
Okay.
But I don't understand what number to use to get to that. But
All right, I'll look at my notes later. I can send them to you.
Okay, thank you. Would you like to number 16, Gabriela?
Sure, I'll do number 16. What is the probability the survey results will show the candidate is losing even though the true P equals 0.52? So we go to, I think we'll put tablet in this one.
Okay.
And I did get the 0.037.
I agree.
Yes, Ben agreed. Okay. Let's submit it. Oh, 100%.
All right.
I'm gonna just take a real quick while I'm here, a screenshot of that question because I want to make sure I
Okay.
figure it out. Okay, thank you. All right, I think
Thank
that's
you very
it.
much.
Now, do you want to talk to Gabrielle about what we were talking about? If we do need to meet as a group for the project?
Okay, I will talk to her now.
Okay.
Thank you, Ben.
So, did we plan on meeting at like 8:30?
Yes, sorry, Ben. We talk about meeting Thursday at 11 a.m.
No, I thought we were gonna meet it just a little early. We were gonna still do the 9 o'clock at night. Am I not planning on that?
Ah, okay. Would be Thursday, 9 a.m.
No, 9 p.m. is what I thought. Just like we've been
Oh,
meeting. But I thought we were gonna meet
okay.
like a half an hour early
Oh, okay.
because of the group
Okay.
project.
What do we want to do?
Okay, Gabriela, because we have to work in our group project, maybe we can meet next Thursday at 8:30 p.m. Is that okay, Ben?
That would work for me.
It works for you, Gabriela?
8:30 p.m. Yeah, that's fine. Yeah,
Okay, Gabriela says
that will be
okay.
fine.
Okay.
Okay, so,
Excellent.
okay, thank you. I appreciate your help.
Thank you.
Good night. Bye-bye.
Good night.